Welcome to Real Civil YouTube channel. In this video, we are going to cover the seismic waves. In last lecture, we have covered the elastic rebound theory. Now we are going to cover the seismic waves. We will see the theory as well as some animations so that our concept get clear. So basically, seismic waves are classified as body waves and surface waves. There are two main classifications. Body waves, the waves travel through the earth in all direction and to all depth. That means suppose this is our earth. Okay, so they travel deep within the earth. Okay, that's why we called it as a body waves, because inside the body of the earth, and those travels on the surface are called as surface waves. So basic classification is body waves and surface waves. Body waves are again classified into two types of waves. First one is the primary waves, also called as P waves, and secondary waves, also called as S waves. So let's study primary waves in detail. We know that primary waves means P waves. So there are many different names to these waves. First name is the primary waves. This is also called as push-pull wave. It is also called as longitudinal waves, also called as compressional waves. So these are all same: primary waves, push-pull waves, longitudinal waves, and compressional waves. So let's see the how it propagates. So these wave propagate by longitudinal. Longitudinal means suppose this in this direction the wave is propagating, then there will be a compressive action, which means that the ground is alternately compressed and dilated in the direction of the propagation. Means what? If the wave is going through this, then there will be compression, then there will be dilation, then there will be compression, then there will be dilation, like that. We'll see the animation. Right now just focus on this P wave. Here you can see it is getting compressed, then dilation, then compressed, dilation, compressed, dilation. And this is the direction of propagation of the wave. So this is how the P waves travel. Don't look at S waves right now. Now there are some properties of the P waves. P waves means primary waves. These are the first wave to hit the earth surface. When they come from the interior, they are the first to hit the earth surface. Their speed is generally 8 to 13 km per second. Therefore, when an earthquake occurs, these are the first waves to reach any seismic station and hence first to be recorded. So whenever earthquake occur, these waves means primary waves, as they have higher speed. So that's why they reach to any earthquake station first. That's why they are recorded first. These waves travel in a linear direction, and they can travel through solid, liquid as well as the gas. There is one formula to calculate the velocity of the primary waves. So this is the formula where here E is Young's modulus, B is Poisson's ratio, generally considered as 0.25, and rho is the density. So this formula is generally used to calculate the velocity of the P waves. Again, don't look at this figure, just focus on this figure. This is what they make: compression, dilation, compression, dilation, and this is the direction of the propagation of the wave. Now let's quickly move to the secondary waves. Again, there are many different names. Shear waves, also called as secondary waves, also called as transverse waves. Okay. Now let's see their properties. These waves arrive after P waves. That's why they name it secondary waves. They are arriving late, that means their speed is slow. So they are 1.7 times slower than the P waves. We have seen one name, that is transverse waves. The reason is these waves travel in transverse direction, means like this. This is suppose longitudinal, then this is the transverse. So like that the movement will be there. Okay, and they can travel through solid only because they need shear strength to travel. Solids have shear strength, but liquid does not have shear strength. That's why these waves cannot propagate through liquid. Transverse or shear waves, which means that the ground is displaced perpendicular to the direction of the propagation. So here you can see the direction is this, but the ground is displaced in this direction, as you can see in this picture. That's why called as transverse waves. You can see how the movement is there, how ground is moving. Direction of the wave is like this, but the ground is moving like this. On this slide, there is a formula of calculation of velocity of the secondary waves. You can just go through the meanings of the terms. It's similar to the P waves. Again, here you can see S waves. They move like this, the particles moving up and down, and the velocity or the direction is forward. Now next classification. First part we have seen body waves. Second part is surface waves. So when the vibratory wave energy is propagating near the surface of the earth rather than the deep in the interior, so they are associated with the surface only. So there are two types of the surface waves. First one is the Rayleigh wave and second one is the Love wave. These are called surface waves because their journey is confined to the surface layers of the earth only. Surface waves travel through the earth's crust, which is the topmost part, and they do not propagate into the earth's interior like P and S waves do. They are traveling in the body of the earth, and they are R waves or L waves are traveling near the surface. They are the slowest. Surface waves are the slowest. As they are slowest, that's why they are last to be recorded on the earthquake station. Generally, their speed is 4 to 5 km per second. Now let's see the effect made by the love waves. So they cause horizontal shearing of the ground. Their movement is like they move in a much the same way as a snake slithering across the ground like this. We know that snake move like this. Okay, so they move the ground horizontally. In S waves, we are seeing like through the elevation point of view, and for love waves we are like watching like a plan view. Okay, so from the top view we are watching, and S waves like we are watching from the front. So they move like a snake slithering. Okay, so they vibrate in a perpendicular direction compared to the wave motion. We know that wave motion is like this, but the ground is displaced like this. This is through the plan view, from the top view, and they are most destructive. Now if you talk about Rayleigh waves, we'll see the picture. Rayleigh waves, love waves, how they move in the next slide. So surface waves that cause both horizontal and vertical movement with the ground, means side by side as well as up and down. So we can say that motion as a rolling motion. We can call it as a rolling motion, and this is most destructive. So here you can see the P waves, compression, dilation, compression, dilation. S waves, they are going up, down, up, down like this. But S waves, they are moving the ground horizontally like that. Here you can see like this. Okay, whereas here there is a rolling motion of the R waves. You can pause and you can see again and again so that it gets clear how these waves moves. Okay, thank you for watching the video. Please like, share, subscribe the channel. If you have any doubt, you can comment me. We have covered different points in the earthquake engineering. Like today we have covered seismic waves. In last lecture we have covered the elastic rebound theory. Before that, uh, plate tectonic theory and continental drift theory, then internal structure of the earth. Just go through these videos. If you have any doubt, you can comment me. Thank you so much.